Hello again, good afternoon, and welcome back to the group exhibit for hydrogen fuel cells and batteries at the Hanover Fair 2016. My name is Michael Sinclair, and I'll be the moderator for this next discussion. Anyone standing, please come have a seat. There is table service and refreshments. Please enjoy the discussion. Questions. If anyone has any questions at any time for our guest, please don't hesitate to raise your hand. I'll bring the microphone to you so that everyone can hear the discussion. This afternoon, I have the pleasure of moderating a discussion called Fuel Cell Products for Commercial Vehicles. Joining me on stage is the President and CEO of US Fuel Cell. Please join me in welcoming to the stage Abbas Goodarzi.
Hello, Michael. It's a pleasure to be here.
Thank you, Abbas.
Thank you. Thank you.
So, you can begin maybe the discussion with just a brief introduction about US Fuel Cell and what you guys do.
US Fuel Cell is a manufacturer of fuel cell engines for commercial vehicles, which is designed for the commercial vehicles environment in terms of shock, vibrations, and also for the required operational life.
So why does US Fuel Cell why have you focused on commercial vehicles?
Commercial vehicles have a defined end user or defined operation. So you will be able to actually qualify for your customer what they're going to earn in terms of both fuel economy, operational cost, as well as the emission reduction. Also, fuel cells are added cost. Doesn't matter how you look at it, it's added cost. So a commercial vehicle usually operates maybe 8 hours, 10 hours, 12 hours, 14 hours. So therefore, by focusing on commercial vehicle, you actually operate a longer time. So it gives you the best advantage to have a better operational lower cost because of the hours accumulated, and also a lower total emission reduction. But on top of that, in many countries, including United States, the commercial operators are under a more stringent requirement than conventional vehicles or the passenger vehicle, which tend to be not utilized as much.
More stringent requirement for what?
For emission, and also they tend to be richer, so therefore they can afford. A commercial vehicle is usually a much higher cost. So when you look at the incremental cost of the fuel cell engine to a vehicle, that incremental cost is not as significant. Whereas if you try to apply this thing to a passenger vehicle, it becomes really non-affordable. And the commercial vehicles tend to operate around public. So therefore, they get two benefits. They get fuel economy and emission reduction, but there is a perceived social image, there's a perceived being concerned operator that is added value to them. Yeah.
So these vehicles are, where's the fuel for these vehicles?
These vehicles, most of the fuel cell utilized for transportation is PEM fuel cell. And PEM fuel cell, main fuel is the gaseous hydrogen, which is usually stored in a tank. Just like a natural gas tank, same design except a different valve. So all the design is compatible with the hydrogen. But it's the fuel cell runs on gaseous hydrogen. And that storage is usually pressurized tank or sometimes non-pressurized tank, as our previous speaker said, in a metal hydride type.
Now, you're based out of Los Angeles in the U.S.,
That's correct.
and I don't really know much about the hydrogen distribution network in the United States, but it does also occur to me that perhaps fleet vehicles, commercial vehicles are also popular because you can control the project of the distribution as well.
That's correct. Our company is in Torrance, California, which is about, I would say, 20 kilometers south of Los Angeles, and about 12 kilometers from the port of LA, port of Los Angeles. And there is 2 fueling stations within about 3 kilometers of where we are. And the state of California, as well as New York or Northeast, they have a plan. They have installed, I think, up to 22 fueling stations for the general user. So the idea is to have a fueling station installed in sufficient range that presently you can operate anywhere in Southern California and you have access to fueling station. You can even drive from Los Angeles to San Francisco, which is in kilometers, roughly about 650 kilometers. There are 2 fueling stations on the way, depending on which one you want to use, that allows you to operate that. So there has been substantial investment to go into the fueling infrastructure.
Very good. And what's unique about your products and services?
Most of the end user, most of the present product is they try to adapt the vehicle to the fuel cell engine or the fuel cell power plant. Whereas what we are doing, our fuel cell is just a fuel cell engine. We adapt our fuel cell to the existing vehicle. So the command, control, communication, integration into the vehicle is the same as conventional engine, either is diesel or natural gas. Also, most importantly, the way it's operated is very similar to the engine. We are doing this to make it easier for the vehicle manufacturers, to the OEMs, to adapt and utilize this new engine. So really, we have the diesel engine, compression ignition, we have the natural gas, or we have the petroleum, and we have the hydrogen. And this way, the engine is made to be compatible with the existing vehicle structure, so we do not have to redesign the whole automotive industry that has been built for over decades and centuries.
The strategy seems like it does make sense. Although, I mean, these technologies, they are different than conventional engines. What does that mean for service and maintenance of the vehicle?
This is a very good question, because most of the customers that we deal with, you have the finance people who are concerned about budget for purchase of the vehicle. But that is a small concern. Most of the concern comes from the operator, the dispatch person, who says, okay, I'm going to be changing some of my existing vehicle to fuel cell. How confident am I that these vehicles are reliable, number one? Number two, what do I need to do to train my service people to be able to maintain this vehicle for me? So what we are doing is we are making the service and maintenance and the diagnostic of these fuel cell engine to be exact standard J1939 as a conventional diesel or gasoline engine. So even the same equipment you use with your diesel engine or a natural gas engine, the same service depot equipment can be used to service this, because training the service people is a major cost. Most importantly, it's a major learning curve. It's a major risk that now you have a service people who have to go through multiple training to maintain that. And that would impact the operational cost. And when we look at the vehicle, or any kind of engine or any kind of component, you have a capital cost and you have operational cost. We call that life cycle cost. And bringing down the service maintenance is as important as bringing down the cost of the initial equipment, because it is, for the end user, it's a cost.
Your customers seem to me like they're very educated. They have a fleet to manage, and they're very good at their jobs. You mentioned that you need to, there are some convincing to be done to convince them that fuel cell technology is the right direction for them to go and that the vehicles will be reliable. How do you go about convincing these decision makers that fuel cell technology is going to be the reliable technology for their fleet?
Well, it is a toughest job for us. The technical part is one thing. To build confidence for the end user is another thing. And in America, all of the public transit companies are losing money. So it's just subsidized so they can reduce traffic for the rest of the people. So therefore, in terms of budget, we have to convince them of two factors. Is that when they commit to these vehicles, in return, they have to answer to the riders. If that vehicle is not reliable, they will lose credit with their riders. So therefore, we have to ensure that these vehicles are as reliable and as safe. For example, when we deployed the fuel cell transit buses first time, people would always be concerned looking at the bus, do I want to ride this bus or not? There was a lot of what we call perceived notion of the safety. Oh, this is gaseous hydrogen. Oh, this is gaseous natural gas. Pressurized tank, or so and so. But after 6 years of operation, this is 13 vehicle, 6 years of operation, in a very diverse community of AC transit, which is San Francisco, Richmond, Oakland, it's a very wide area. People actually wait and prefer to ride these buses. And these buses are operated 14 hours a day. And that is the biggest win for us, that the transit operators is earning respect, credit, and acknowledgement from the riders. That's why they're coming asking for more of these vehicles. Otherwise, if that service was not that good, we would not have the second sales. So this is how we build confidence with the end user, by being reliable and making sure they need to know how to prepare for it. Be trained, have the training tools for their operators, for the drivers, and for their service people.
You've touched on how critical the economics of the vehicles are to these fleets and to the operators of these fleets. And also you've touched on the 2 points. You have CapEx, initial upfront costs, and you have OpEx, the operating costs of these vehicles. Can you give us a sense of how your vehicles compare, these fuel cell vehicles compare against their diesel counterparts?
That's a good question. Let's just go by what we have learned, what we know with the actual operation. 13 buses, 6 years. Operational cost comparable to diesel engine. And these are not the so-called 2010 engine with the SCR after treatment. These are the older diesel engine that still don't have as much sophisticated as of after treatment. And the service and maintenance per mile, dollar per mile, is comparable. These vehicles, in terms of miles before road calls, how many miles is each bus in average is driven before the bus is broken and they have to send in another bus to transport the vehicles. These vehicles, fuel cell buses, after 6 years of operation, not brand new, not midlife, 6 years of operation, they're offering similar miles before road call, if not better, than diesel engine, and definitely better than natural gas engines. For some of you audience, you may not be aware, in California, you cannot operate a diesel engine. Absolutely not. No diesel engine bus is allowed. So what is your choice? Your choice is either natural gas or is the zero emission, which is either battery electric or the fuel cell. So really, the choice for California is very clear for zero emission going forward.
Reduced carbon dioxide emissions is one reason that people pursue this type of technology. I guess, what are the other key factors that drive demand from your customers?
There are some key factors, there are some lessons that we learned that we were not expecting, we were not anticipating. The fact that there is no engine noise, we never pay attention. But we know that riders pay attention. The reason they wait for this car is because it doesn't have noise. You don't have that rattle inside. Now you have the citizen riding the cars have communications. These are the things we did not think about it as much. Number one. Number two is, as they're pulling in, you don't have that smog coming out. So really, the riders are making a choice that this is more convenient, less noise. By the way, we do the same thing with some of our special equipment that we provide for off-road, is that the noise of the vehicle, that the end user have to have an earphone. And then after every 6 years or so, they have to retire because they're losing hearing. These are the added value that we have seen that these vehicles provide. So it's not all about fuel. It's not all about greenhouse gas. It's not all about NOx, but also about the quality of the service that we provide. Imagine if you have a metro or a silent train service on a bus. Of course, because transit agencies, bus is competing with the light rail. So if we do not provide a better service, we will lose riders.
These are hydrogen vehicles, and you mentioned that in California there's a number of hydrogen filling stations available for the public to use. Hydrogen doesn't have as wide a distribution as other fuel technologies. How do these municipalities that are buying your buses, how do they ensure their supply of hydrogen in their local areas?
Well, for the transit buses, there has not been an incident that a bus could not be deployed because there is no fuel. 6 years. And the supply people have done a good job. You have a supply base either generated locally or has been brought in remotely. But for this incident, for this operation, we have not had an incident that the bus could not be deployed because there was no fuel, or there was no dispenser, or there was no infrastructure. It really did plan well. Another item that I like to point out is that all the safety element, both in fueling infrastructure as well as vehicle that design in, it worked as it was supposed to. We have not had a single incident that will think us that there is a fundamental design problem, fundamental engineering problem. Really, the issue is now more of a commercial and cost rather than technical. So really, the fueling infrastructure is not a part of our forte, but I can report they haven't had a single bus couldn't go dispatch because they were out of fuel. We did have vehicles that the drivers forgot to fuel. It does happen, especially during a payday, that kind of things. But we haven't had an incident that really impacted bus not being able to provide service because the fuel wasn't there.
Clearly, you have a very practical, demonstration, large-scale demonstration of the technology. I guess maybe my last question. Well, first of all, I'll throw it to audience questions. Is there any audience questions at this time? No, so that's fine. Oh, there is one question. Excellent.
You compare it with natural gas. That's the most important comparison in California. Is there also a comparison with the electrical solution?
Correct.
Have they also tried it next to your solutions?
Yes. As we are, California deployed, I believe, 11 electric buses. And they are collecting all of the operational hours, service hours, availability hours, failure incident with the electric. But these are just been recently. So there has not been sufficient comparison of the two. But I think within 1 year we can make a good comparison. My personal observation, my personal comment is that battery buses will be as reliable. There's no questions on it. But the unique benefit of a hydrogen is that I told you they run 14 hours. And they get fuel fast. So this way you have this expensive piece of equipment does not have to be set aside to be charged. And these municipalities have substantial population and limited capital. So therefore, I foresee the reliability of the batteries to be as good. Battery vehicles are as good for the limited range, whereas fuel cell have all the convenience of what we are familiar with in terms of natural gas or diesel.
Well, everyone, thank you very much. Unfortunately, we are out of time for this discussion. For more information, of course, you can please talk to Mr. Goodarzi and his team over at US Fuel Cell. They're located at booth C34. Of course, if we could all put our hands together and thank Abbas here for joining us on stage today.
Thank you. It's a pleasure to be here.
Oh, you can, okay. Abbas, thank you very much.
Thank you.
There is another discussion coming up next. It's entitled Efficient, Compact, and Cost-Effective Fuel Cell Air Supplies. Joining us from Varex Air Systems is Ski Muir Milburn.